The COVID-19 pandemic has had huge impact on everyone's life. While the virus has been spreading to every corner of the world, schools and business have been shut down, store shelves have been emptied, and people have been forced to stay at home. In many infected areas, hospitals are overwhelmed. In such a challenging time, accurate and timely information on pandemic is crucial to overcome the difficulty and save lives. One of the websites for tracking the number of COVID-19 cases is a dashboard developed by a team from Johns Hopkins University. But the vast majority of the data that powers the dashboard is manually collected and confirmed. They need a dedicated team to go to different websites, find the data, and save them in their database. And this may surprise many people. As humans, we can consume the digital information on the internet effectively. So why can't computer? Why is it so hard to share and consume data between IT systems of different organizations? The answer is that there is no single wide adopted technology that allows the computer system to easily understand or pass the data from other systems. For example, the data stored in a local relational database is described using entity relationship diagram. This diagram is a graph with nodes and links representing entities and their relationships. This leads to the next question. Why can't we build such a diagram that can be shared by all the databases and the computer system? Like Wikipedia, we can enlist all the domain experts and developers in the world to build such a knowledge-based diagram collectively. We may call such a diagram a global schema or ontology graph. It will become a common language to bridge the gap between different systems and organizations and allow data to be shared and consumed freely. For Johns Hopkins team, all they need to do is a one-time setup to find the proper data sources and retrieve data from them through their user interface or SQL-like programming. The dashboard will be able to fetch new data every day automatically, and all the human effort of manually entering data from websites into the database will be eliminated. The researchers could focus on finding cures for disease to save lives. The challenge of building such a global schema is the complexity and ambiguity of real-world data. As you can see, the ontology graph of even very small domain can be overwhelmingly complex for humans to manage. Not to mention that we want to create such a graph for all the data in the world. To solve this problem on our platform, we introduce a novel and flexible classification scheme to hide the complexity of the underlying graph. For domain experts and developers, although they are creating the ontology graph, they never need to see it. What they work on is a very nice classification tree that they are free to improve and customize. This example of type tree. As you can see, we can traverse down the tree from root to find the type we want, such as type pandemic. On this platform, the categories of things are called types. Each type has its properties. Both types and their properties are organized in classification tree just like this one. The concept of classification here is similar to traditional biological classification, but in a much more flexible way. For example, each type can be divided into subtypes in different ways. Each way is called a type classification. Here is an example of two different classifications for type thing. In this example, entity is classified as a subtype of thing in classification 1, but is classified under type object in classification 2. Also, two object types in these classifications are not the same, even they share the same name. It's because one does not contain type entity and the other does. On the other hand, type event means the same thing under both classifications. It's time to take a look at our website. On our website, users can browse type trees by expanding a type. Its subtypes are shown based on the default classification. They can change the classification for any type. When a classification is changed, the type tree is changed. So there are exponential number of the type trees. That's how flexible this approach is. Domain experts can update type trees, make changes to types, type classifications, property groups, and so on. This is a web page to add a type classification. For data publishers, they may publish their data sources and associate them with types and properties. And this is where data turns into knowledge. For developers, they can search data sources based on the semantic meaning of the data they're looking for. Let's explore the type tree a bit more and do some quick search of data sources. When we browse a type tree, we can use type classification to shape the tree itself. For instance, we can change the classification of type thing. In this case, we choose a classification where person is a subtype of thing. When we come back to the type tree, notice that the new classification is used. Now assume that the data source we want is about the total number of cases in a pandemic. One way to find them is to traverse down the type tree and find type pandemic first. Then traverse down its property tree to locate the matching property called total case numbers. From here, we can go directly to the search page. In the data source search page, if we don't specify any conditions, all the data sources associated with the property are listed. Here's the result. We can filter the result by adding conditions, like the ones used by SQL or GraphQL, except that all conditions can be much more expressive due to the underlying ontology graph. Whether a data source is a match or not depends on whether there's a conflict between search conditions and the data source scope. You may wonder what technology we use to build this website. Under the hood, this platform is deployed on IBM Cloud, utilizing its popular Kubernetes service. Here are the open source software we use to build the prototype of this platform. In summary, there are many technical benefits offered by this knowledge-based data hub as shown on the screen. But you may ask, what does it mean to us and a pandemic? Well, it means the data are turned into knowledge that your computer and a smartphone can understand. It means when a doctor updates the case number in her hospital, you can get the information instantly from your app. It means when a prescription needs to be refilled, your phone can seek offer from any pharmacist and place order for you automatically. It means many things, and all this can be achieved at no additional cost, thanks to the fact that your app can not only get the data, but also understand the data no matter where it comes from. In terms of future implementations, there are so many things we can do to improve the platform and make it more powerful, from adding instant databases and upgrading user interface to implementing duplicate detection methods. Most of all, we can develop better AI systems because on this platform, data is not data anymore. They are transformed into knowledge that both human and the computer can understand. When this platform is widely adopted, our lives will be changed forever. Thank you for watching.